Alright, if you watched the previous projectile motion technique video, it started with a projectile that started and ended at the same height. Okay? The next example is going to be when a projectile starts at a higher height and then maybe is shot into the sea or there's water or something. But the idea here is that we're starting at a maximal height and the projectile is going down. Okay? In this case, beware, because they're either going to need to tell you one value, either the height of the cliff, or they will have to tell you the horizontal range. But you can't solve the problem if they don't tell you either of these values. So just keep that in mind. But I'm going to show you the example when they give you the 100 meters, which is the height of the cliff. Okay? So let's go back to our original steps. And the first step is to split the initial velocity into its x and y components. Okay? So normally projectiles are shot at an angle. But because this one's already at the top, we're just shooting it straight. And so all of the velocity is already in the x direction, and so I don't have to do any trig. I just need to recognize that my v initial x is equal to 20, and my v initial in the y direction is just equal to 0. Okay? So that's a really important thing to recognize off the bat. Okay? And remember, physics comes down to understanding your fundamentals well. If you have strong fundamentals, you can typically solve any difficult question. Alright, so now that we have our x component and our y component, let's go ahead and solve for the time of flight. Okay? Again, the time of flight is best solved by using the y-axis. So I'm going to say time is equal to question mark. I know that my initial velocity in the y direction is equal to 0. I know my acceleration in the y direction is equal to negative 10. And I know that my displacement in the y direction, or my height, is equal to negative 100. Now keep in mind why I wrote negative 100, because displacement is equal to a final position minus initial position. So my final position will be at a height of 0. My initial position is at a height of 100. So when I subtract them, it's 0 minus 100. Okay? So I have three variables that I know, and the one that I'm missing is v final, which I don't care about. So I'm going to choose to use a kinematics equation that does not include the final velocity. Okay? That equation is going to be displacement in the y direction is equal to v initial y times t plus 1/2 at squared. And since my initial y velocity is 0, that part cancels out. And I get negative 100 is equal to negative 5t squared. I divide by negative 5, and I get 20. So t squared is equal to 20, or t is going to be approximately, it's going to be between 4 and 5. So we'll go ahead and say 4.5. Again, we could get a more precise answer if we were using a calculator. So time is equal to 4.5 seconds. And that's how long that this projectile is going to stay in the air for. Well, the nice thing about once you solve for time is that time links the x-axis and the y-axis together. So the amount of time that something is in the air for in the y-axis will be the same for the amount of time that it's in the air for in the x-axis. And now I can finally plug it into the final part of this technique, which is to solve for the horizontal range. And we're going to use the equation that dx, or displacement in the x direction, is equal to v naught x times time. And so dx is equal to 20 times 4.5. And so my horizontal range is going to be about 90 meters. And so after this projectile leaves the cliff, it is going to land 90 meters away from the edge of the cliff. Okay? Alright, the next video is going to show how to do the same problem if they give you the horizontal range rather than the height.